presentation is designed to be like a follow-along workshop. It'll make the most amount of sense if you have your laptops out and are following along with us. We originally intended for you to actually install Cryosis and run everything on your laptop, but never know if the internet is good enough, and the amount of Docker images you would have to download is about 6 gigabytes. So decided to do everything on Gitpod. So that's how we'll do it. So you'll just need a laptop and a GitHub account to actually walk through everything. So welcome to our workshop. It's all about custom Ethereum devnets for consensus and validation testing. The workshop agenda, first we're just gonna run a very basic testnet. It's gonna have one full node only. It's gonna be a Geth and Lighthouse pairing. And then we're gonna move on to something a little more complicated with three full nodes. We're gonna change the client pairing between the EL and the CL layers. And we're going to show how we can have 128 different validators, because each node can have multiple validators. And then we're going to show you what it looks like to run with full PBS emulation. We're going to run the full MEV Flashbots infrastructure set. And while we're doing that, I will show you how it looks over Kubernetes. You're not actually going to set up your own Kubernetes cluster in this demo, but I'll show you that Cryosis, you can run it over Docker, which is what most of these things are, over Kubernetes as well, without having to worry too much about changing anything. So, like I said before, what you're going to need is just a laptop and internet. We have the internet. Hopefully you're connected to the event internet, and a GitHub account. So, to start, we'll run this via a Gitpod instance. So the URL is here. It's short url.at/g-j-s-z and then uppercase Q. You can run into that Gitpod instance to open up Cryosis. We also have a bunch of Cryosis team members around the audience to help out if anything is going wrong, going poorly. Just yell at them and they'll handle it. So I'll leave this up here again and repeat it real quick for people who might not be able to see it too well up here. It's short url.at/g-j-s-z uppercase Q. Give a little bit. Show you what it looks like here inside of that short URL. Great. You should see something like this. It might prompt you if you want to submit your email address. You don't just, if you hit enter with nothing, it'll be fine. That's optional. Let's see what if my connection's working here. There we go. Okay. Is anybody still waiting for a screen that looks something like this to pop up? Got one? Cool. The very first thing we're going to do is we're going to run it's called the Ethereum package. The command is going to look like Cryosis run github.com/Cryosis-tech/Ethereum-package. It's just going to look like that. I'll try to zoom. I'm going to zoom in a little bit here. Let's see if it works. Oof. There we go. It looks something like this. Cryosis run github.com/Cryosis-tech/Ethereum package. So the way Cryosis works is environment definitions are in things called packages. And a package kind of contains all of the setup logic that's involved for spinning up, in this case, an Ethereum testnet. And with Cryosis, you just point it to a GitHub locator, and it's going to pull everything it needs from that GitHub locator to spin up what you need. So when we run this, interesting. I lost my Cryosis. Let me see. Sick. Hopefully that didn't happen for anybody else. I'm going to blow away my workspace real quick and then do a new one. Apologies. Boop, boop, boop. So to repeat that command here, it looks like, assuming your workspace worked and mine didn't, Cryosis run github.com/cryosis-tech/ethereum-package. Is anyone attempting to run this and not able to do it or hitting problems? Awesome. Apologies while you're doing that. I'm going to keep reinitializing my own Git pod here. Now, what you should get out of running this command is you'll see an output that kind of lists all the things that Cryosis is doing. It's spinning up an EL client, a CL client, a bunch of helper services. It's putting the Genesis data where it needs to go. It's getting you the validator keys you need to get. It's going to do all that stuff. And at the end, you're going to see a bunch of an output that tells you all of the stuff that's available. And you should see, if you're in Gitpod, you should see a list of URLs. And the URLs are port exposures. So any relevant application ports, including Explorer front ends and all that stuff, they're going to be available to you on your local machine. If you're in Gitpod, you're going to use the Gitpod port forwarding, and it's going to work fine. And I think I am almost back on track here. Yes. Okay. All right, hopefully this one's going to work so you can see it live on screen here. All right, so you can see it's downloading all of the Ethereum relevant images. It's going to need to download ethpanda ops python web3. You have some observability tooling and some spammer tooling. Spammer, what I mean is like transaction fuzzing and like sending activity through the network. That's kind of just basic activity, so you have some degree of transactions to work with. Grafana, Prometheus, and a couple different explorers. This, the entire package that we're running, by the way, on GitHub is an open source asset. I'll show you where it is on GitHub. It's an open source asset that is jointly maintained between, I'll show you, between Cryosis and a couple of folks in the Ethereum Foundation, Pari, Barnabas, PK910, SamCM, and we have contributors from across client teams and different block builders that have contributed to this. So it's a community effort that's still growing, and as you get comfortable with it, you can also become one of the contributors or maintainers. So back to my Cryosis that's running now with the default configuration. It's As it prints, it's printing out all the stuff that it's doing. It's showing me exactly what Kurtosis is adding as it's adding. And then here's the view that I wanted to show you earlier. You can see that I have port bindings exposed everywhere. I have a CL Lighthouse Geth service, and what that is that's represents the Lighthouse node. And then I have the beacon chain kind of part of Lighthouse, and then I have the validator part of Lighthouse, and then I have the Geth node. And the RPC ports are exposed, and I can show you that Dora, which is a lightweight explorer, comes with the whole system, and you can click into Dora, and you have a nice explorer for your testnet. We are currently pre-Genesis. You can see that the Genesis is going to happen in 34 seconds here. So we're not going to see much activity yet, but once Genesis happens, you're going to start to see slots come through, and you will also be able to go to your validators screen, and you'll be able to see all of the validators that you've deployed in your network. There's one node running here, but each node has 64 validator keys tied to it, and that's why you see all of these entries here. Yes. Great. Does this make sense so far? Is there anybody still working on this step? And if not, we can go to something a little more fun. Gianni. Cool. What we'll do in the next step is, and this is one of the big benefits of using this package that we've built, is you can pass in a high-level JSON configuration, and that JSON configuration will specify things like the ELCL client pairings you have in your network, how many instances of each ELCL client pairing. You can also specify additional services, like more advanced explorers or like the MEV infrastructure. So we'll show you some of that. So to start doing that, we're going to do something a little more complicated. So if you can go to this GitHub URL, it's github.com/kurtosis-tech/summit. And once you're in there, you'll navigate to something called complex.yaml. That complex.yaml is a starter configuration file for something that's going to be more exciting than what we just saw. And then once you have that open and on your machine or in your Gitpod, then we're going to change it together a little bit. So github.com/kurtosis-tech/summit, and then go to the complex.yaml. And in just a second, I'm going to move my screen over to go to GitHub to show you where that thing is. Cool. github.com/kurtosis-tech/summit. And once we're in there, we have complex.yaml. And you can see a YAML configuration that this is going to give us a different testnet. And you can see that there is a Geth Lighthouse pair, a Nethermind Prism pair, and a Reth Teku pair in this testnet. So 3 different nodes. And we also have a couple of different additional services specified. Here? Yes. Yeah, hopefully that's good. Yeah, it's going to be easiest to be able to copy and paste this, because I'm going to move out of the screen just a little bit to show you what we're doing. But let's make, in Gitpod, let's take this and let's make a file. Let's make a file here called complex.yaml. Keep it simple. And then let's paste the contents of the file in GitHub into that complex.yaml. Here. Cool. Now, once you have that, is there anybody who's still getting to this spot? Great. Give a little pause. And if you're curious, as we're catching up, if you're curious about what the exact options here for this YAML, this JSON are, if you go to the Ethereum package in GitHub, you can see a full spec. Oh. Where is this? In the editor. Here? Oh. There's a typo. Let's see. Is it everywhere? It is. Okay, on line 9 of your YAML, if you see network, that's not a word. It's going to be network, network underscore params. Yes. Thank you. Ah, that's why I didn't catch it. Got it. Got it. Cool. Network, net W0, O, RK params. It's going to work. Cool. And now, so with this as the base, what I want to do is I want to edit this a little bit together to make some changes so you can see what it's like to do a little bit of configuration on your YAML. So on line 8, we're going to set this key. We're going to set this key Ethereum metrics exporter enabled to true. On line 10, we'll change the number of validator keys per node to 128. And then on line 11, under additional services, we'll add the following. We'll add full underscore beacon chain underscore explorer. And that's going to give you a more advanced explorer than what we saw with Dora. It's a little more heavyweight, but it's going to have a different set of visualizations that is going to be nice and useful for you. So I'm going to pop back and forth now as I do this too. So Ethereum metrics exporter enabled. I'm going to change this one to true on line 8. And then the next one is changing the number of validator keys per node to 128. So what I'll do is go to number of validator keys per node, change this to 128. And then also under additional services, I'm going to add a new additional service, and it's going to be called full underscore beacon chain underscore explorer. Full, like this. Make sure I got that right. Full underscore beacon chain explorer. Okay, this makes sense. And now we can go to our terminal. Pull this up. And we can run cryosis, run, it's going to be github.com/cryosis tech /Ethereum package. And then we're going to have an additional command line argument, --args file. And then you're just going to pass in complex.yaml, which is the args file that you just created. And if you run that, then cryosis is going to take in those arguments, and it's going to change the setup of your testnet. You don't have to stop the previous one. They can run simultaneously side by side, and you should be okay. Yeah, so it's going to download a couple of new images that it didn't have before because we've added new EL and CL clients. We've added a new Explorer. So we're grabbing a couple of these images. This is the main reason why we're doing it on Gitpod instead of on our own laptops, because this would have been a nightmare over spotty internet to try to do all at once. And it's going to do the same thing it did before. The thing that is printed out is called the plan. Every cryosis package creates a plan, and the plan is a sequence of steps that are kind of the fundamental building blocks of spinning up an environment, a multi-container environment. So that's what it's spitting out here, and it's a bunch of stuff that handles the DevOps complexity involved in passing all the different values involved in setting up one of these testnets between all the nodes so that they have all the information they have to have in order to start up. Great. Now we're starting to get the Beacon Chain Explorer, and while it's running, I can give a shout out. I believe the Dora Explorer was built by PK911. Hey, yes, thank you for that. He's in the audience. We can give him. Thank you. It's awesome. Appreciate it. And then Beacon Chain was B-Chain. No. Awesome. So that's what we're gonna check out here. We're gonna check out the Beacon Chain this time. The previous one we saw was Dora, which is still running. It's great. Great, we're almost to the end of this. Let's see. Great, okay. Let me just make it a little smaller so everything fits into this spot. Okay, so now we got a bunch of services. But as I mentioned, we have a bunch of different ELCL pairings here. And all of their most important ports are exposed to you in your local machine so that you can play with them. We have now a new set of exploration tooling available via the Beacon Chain Explorer. And if we go to that front end, you can see the Beacon Chain UI. As before, you can check out your validators. And you can see all the public keys. In this view, we don't see, what type of validator they are, like whether it's Lighthouse, Geth, Lighthouse or Geth pairing or like Teku Prism pairing. Like these things are going to be not immediately available in this view, but you do have a different view for your transactions and for your mempool and your epochs and slots. Now, it's very, we're on slot 9 here, apparently. Cool. Another thing that I wanted to show is that we have built-in Grafana and Prometheus dashboards in these testnets. So if we pop into Grafana, I'll show you a bit of the dashboards the community has put into the package so that you can get some monitoring out of the box. So we just pop into the dashboards, general, and I'll show you we have the Ethereum metrics exporter overview, and it's split into, real quick, I'll collapse these real quick. It's split into an overview, the consensus layer, and execution layer. It's split into consensus spec, overview, consensus layer, and execution layer. And as you dig into these, you get kind of the sets of monitoring that you would expect. Head slot, epoch. I believe in the overview we have memory usage and CPU usage per node, and you can use this to check what's happening as you run your tests. That's the Ethereum metrics exporter overview. It has the aggregation of all these different validators together. There's also another dashboard, which is a single view, where you can actually pick the pairing that you want to look at. And then when you're in that pairing, you have a more in-depth view per node. So just quickly to review what we just covered, when I run the testnet, I have a couple of things. I can configure the ELCL pairings. I can configure how many of each pairing that I get. And once it runs, I have a flexible selection of explorers. I can use Dora the Explorer to start. I can use the Beacon Chain Explorer, which has a bunch of different services that are involved in getting the thing going, but it has different views that I can use. And then when I want to do my observability and my metrics style stuff, I have Grafana, and I have a couple of dashboards that show me per views, either on the aggregate or per EL or per CL client. Cool. Now, there's two more things I'm going to show. One of them we'll do together. The other one I'll just show you while that one is running. But before I move on, is there anybody who's still playing around or getting up to this step? Or am I good to move to the next spot? Awesome. Great. So the third thing we're going to do is we're going to run the MEV software in the testnet as well. So the first thing I want to do is I want to run cryosis clean-a to remove the stuff that I've already ran. It's going to free up some space for me to run kind of a more heavy testnet here with the flashbot stuff running. So going back here, cryosis clean-a, it's going to wipe away all of the containers and the files that were generated in the creation of these testnets. It's going to clean up both of those things. Great. And now what we can do is we can go back to the Summit GitHub where we have the configurations, and we can go to mev.yaml. And in mev.yaml, we have a different setup where we've configured a full mev to be running, and we've also configured some parameters that are, one, going to make it, I think, move a little faster for the demo, and also going to set exactly which images are going to be used for mev flood and for mev relay. So if you can pop into that GitHub and just copy and paste that into a new YAML inside of your Git pod called mev.yaml. And this one doesn't have a typo. So pull that mev.yaml. And this one we're not going to edit together. It should work just the way it is for what we want. And then all we'll do is we'll run a very similar command as before. Cryosis run github.com/cryosis-text/ethereum-package --args file in order to specify the args file. And what I'll do is instead of running complex.yaml, I'll just run mev.yaml. Cool. Now this one is going to take a hot second to run because I want to show you MEV working, and it's going to take a couple of epochs in order for that to happen. So that's going to run, and while that's running, I'll show you how to do stuff over Kubernetes, and hopefully by the time we're done with that and we get back, then everything will be clean and good to go with this. Real quick, just to check. Great. Okay, I'll pop over into Kubernetes real quick to show you what it looks like. And I'm going to do this on my own laptop. So just to show you, cryosis runs not only in Gitpod, but also on any laptop that you bring. And cryosis, it runs over, it can run over Docker or Kubernetes. And the way that you choose between these things is with the cluster setting. So if I was to just set my cluster to Docker, let me make sure my gateway is not running. Yes. So if I set it to Docker, then I'm running over my local Docker engine. And if I set it to remote Kubernetes, then I'm running over a remote Kubernetes engine. And the way that works is in my kube control file, I have a remote Kubernetes cluster set up. So I did that beforehand. That's why I can just type this. But what you would do is you would make sure that you have your kube control on your own laptop configured to your remote K8s cluster, and cryosis will just use that to connect to it. So now I'm on my remote K8s cluster. I'm just going to run one more process here. It's called cryosis gateway. And cryosis gateway enables port forwarding from everything running in cryosis into my local laptop. It'll just make the user experience a lot nicer, and I'll feel the same thing that I saw before, where all of the important ports that are running inside of my enclave, which is the testnet, those are all going to be mapped towards my local machine so that I can access them and do my workflows there. So now that I'm on, let's see, Kurtosis, just to make sure, Kurtosis cluster ls, I am indeed on a remote Kubernetes. And then I can run the package exactly the same way that we saw before. Kurtosis tech / Ethereum package. I can run it exactly the same way as before, just pass in the GitHub locator, and I'm gonna have the exact same user experience, but instead of the deployed target being Docker, it's gonna be Kubernetes on the remote cluster. So it's gonna show me the same exact thing, the steps that it's doing as it's spinning up my network. And then once we get to the bottom of it, it's gonna show as well the list of services that are in the network and the local port mappings. And just real quick, I'm going to check the progress on, yes, MEV. Mm-hmm. Yes. And my CTO is here as well, so he can give you some more detailed answers. The short answer is that right now the administration of the K8s cluster is completely handled by the end user rather than us. And the extent to which you can do very customizable things are inside of the Kurtosis package. You can specify the resources you desire per thing, per service. And then you can also specify custom labels. And that's how you would do stuff like chaos mesh workflows. Because you can specify the labels that get tagged into things, and then your other systems will pick it up. And we're working on persistent environments. So these are designed to be ephemeral, but we're working a lot on the persistent use case. And Kevin might be able to give some better details on that.
So the balance we're trying to strike is not exposing an overwhelming amount of configs, so be making the abstraction useful, but also giving yourself an escape hatch in order to get down to being able to mess with things that you might need. So the balance that we have right now is being able to specify min and max resource limits, so CPU and memory, and custom labels. We don't have the ability yet to do affinities and taints, so being able to specify which node that you want to get allocated, we're looking at that now. What would be a good design for that, something that's not going to overwhelm the user. And then beyond that, like for example, being able to inject service meshes and stuff like that, we don't have that ability yet. It's something we're also exploring.
What about like terraform?
So the question was, what about terraform?
Yeah,
so we would, the way to use terraform to automate all of this would actually be that you use terraform to call down to Kurtosis. So that way Kurtosis knows about all the resources and everything that you're being able to spun up. If you want the very low level control, then Terraform directly being able to like call direct Kubernetes resources, Kurtosis is not going to be a replacement for that. So if you need like very deep control, the idea is that we're trying to provide a much more user-friendly abstraction on top of this.
It looked like you had different kind of clusters that you could set with like Kubernetes and local or Docker, I mean. Would it be possible for someone to contribute their own cluster configuration?
I can take this one. Yeah. Yeah, so one of the question was how difficult would it be? It would definitely be a not insignificant amount of work. But two of the ones that we've contemplated is maybe a bare metal cluster backend, and then potentially a HashiCorp Nomad backend. We don't have either of those. We don't have plans. The bare metal one we're kind of exploring a little bit, but we don't have that yet. But it would be possible. We have an open, you can go to the repo on GitHub and check it out.
And what these values are, You can put any number of Kubernetes clusters onto this setting. So you could have 8 of them if you have 8 of them. That's very much a user set thing, but right now, at least, it has to be either K8s or Docker. Yeah. So, like I said, just to close the loop on that, I mean, all this ran in K8s here, but it is mapped to my local machine, just like it was earlier over Docker in Gitpod. So I still can like click through, for example, to Dora, and then we're gonna see Dora the Explorer, and Dora the Explorer is gonna show us, the slots and the validators that we would expect to see. Cool, and then the same thing works as well. If I want to clean up everything, just get rid of all of those containers and files and everything that's kind of messing up my Kubernetes cluster, I just run kurtosis clean-a, and it's going to clean up all of that stuff, and my K8s is going to be clean from the stuff that I put there before. Let's pop over and see if the timing worked out favorably. Where is my Gitpod? I may have lost it. Oh, here we are. Great. Timing did work out favorably. So my MEV flow has ran. And, I have a couple of services here that are related to the Flashbots infrastructure, MEV Flood, MEV Relay API, Housekeeper website, all of this. Now, if I click into the MEV website, this is where I'm going to be able to see whether payloads have been delivered from the Flashbots relay. And we haven't had any payloads delivered yet. And if we want to see perhaps why, we can pop into, I guess Dora is going to tell us that.
Oh, we need like 28 more slots.
28 more slots?
Yeah, for 40, I think we are 100 right now.
Let's see. We are on the 3rd epoch.
We need the 4th one.
We need the 4th epoch. So
60 more seconds.
50 more seconds?
84 more seconds.
84 more seconds. We can count down together if we want to. While we're waiting for that, let me just pop into the presentation real quick. Let's see. Yes, so just to recap the stuff we saw in Kubernetes while we're waiting for that to happen, we have people using Kurtosis to deploy these test nets on Kubernetes, and then using Chaos Mesh on the same K8s cluster to do chaos testing. There was a tool by Trail of Bits that was showing that at the TrustX talk yesterday to reproduce a finality incident that happened last year on mainnet. And you can do a lot of other stuff there. And it also is useful for doing stuff at higher scale, of course. If you're going to do it remotely, you can scale it up, and K8s will handle all that for you. Great. We're on the 4th epoch, and if we go to Flashbots, let's see what we got for the boost relay. We're starting to do payloads. Yes, so we have Flashbots actually delivering payloads to the network now that we are on the 4th epoch of our beautiful testnet. Great. Now that is it for the workshop. You can open it up to flexible questions if you like, and also we have a QR code so you can scan it and get to the Ethereum package. I imagine if you wanted to go there, you've already gone there probably over the course of this. But the Kurtosis folks are on the crowd. Yes.
So how useful would you say is it for execution layer testing? Because there's a lot of kind of existing clients for execution layer testing. Think Hardhat or Anvil, for example, in the Foundry stack.
Mm-hmm.
How useful is it, or is it possible to add those into this stack and kind of have like a both consensus layer and execution layer testing suite kind of combined? I know that there's probably a lot of trouble with hooking that stuff up to each other, but maybe you have ideas.
Yeah, I think a lot of the execution stuff works really, really well with basically like EVM simulators and people that really focus on the EVM testing side of things. So I haven't yet seen like EVM style or like DApp layer testing working well with Kurtosis. The way I would do it is I would try to combine those tools into the network to the extent that any of those tools can connect to like full nodes that then have different consensus layer configurations. The other like place where it would be very interesting is if you're doing things with like oracles or other like side services that you would want to have hooked in to a full node, and you want to see how that thing changing impacts how your smart contract is moving, because then it's like more realistic. Cool.
I'd love to hear.
So basically, entire Hive tests, which are being spin up on every release, on every testing phase of the EL and CL, are using Kurtosis as well. So the Kurtosis is spinning up the local testnet, and transaction spamming is happening, and plenty of thousands of tests are being executed for each devnet, each before shadow forks, etc. So this is like highly appreciated for us and very helpful. And on the other side, which I'm doing right now, we are helping FlashBots team directly about comparing two versions of builders, testing the performance, and we are using Kurtosis, and we get tons of help from the Kurtosis team about the MF flat. So we are using it very heavily, and I guess it's already starting to help the FlashBots team about UPRs, and Builder Star is open source right now. So this would be some kind of like improvement, like performance comparison of the latest version comparing to the PRs which will be pushed to the builder. So that's the current use case which we are like closing up this week. So those are the things.
And I can add one more comment on this. So the packages are designed to be written in a dialect of Python, and you can import packages into other Python scripts and then build extra stuff on top of them. So basically, we have an import system, and then you can say, hey, like slam together any bits and pieces that you want to form new packages. So if you wanted to add something on top, add an oracle, or maybe like add a dApp server or something like that, you could totally do that.
More questions? Then let's thank the speaker again, and thank you.